And welcome back. So we're taking a look at properties of functions. This is a second in a two-part video series here. What we want to do is finding properties of functions. The next thing that we want to take a look at is the average rate of change of a function. So how is the function changing from one point to another point? Really, the average rate of change is nothing more than slope. So we take a look at the definition here. If a and b, a not equal to b, are in the domain of the function, and y is the same as f of x, then the average rate of change from A to B is defined as change in y over change in x. So delta y over delta x, we've used that before. And so that is just the slope. And what is the slope? Well, it's the change in the y values. The y values, another way to write that is the y value in x is b is f of b. The y value in f of when x is a is f of a. So we're subtracting the y's. And of course, b minus a is a difference in the x's. The little caveat, A is not allowed to be B, otherwise we're at the same point and the change is undefinable because you're moving from one point to the exact same point, so you're not moving at all. So that would be just a caveat there. Let's take a look at these items and find the average rate of change of f of x if f of x is 3x squared, and let's go on letter A from 1 to 3. So let's see, so the average rate of change is going to be the change in y's over the change in x's. So we want f of b, so let's call this a, let's call that b. So f of 3 minus f of a, so f of 3 minus f of 1 over b minus, b minus a, so 3 minus 1. Now we can do a substitution because our f of x is 3x squared. We can come back through here and say, all right, I want 3 times 3 squared. That, in this case, is f of 3. Now let's figure out f of 1. So f of 1 would be minus 3 times 1 squared. And let's see, so that would be f of 1. And then we get 3 minus 1 is, of course, 2. So as we take a look at this and finish going, big order of operations question for us here. So let's see, 3 squared is 9 times 3 is 27. 1 squared is 1 times 3 is 3, so minus 3 over 2. So we've got 24 over 2. So our average rate of change from 1 to 3 is going to end up being 12. Okay? So that is our change in y over our change in x from 1 to 3. And as we look at this, again, the average rate of change is nothing more than slope. Taking a look at letter B, again, we can go from 1 to 5. So let's see our average rate of change in y over change in x. We want f of 5 minus f of 1 over 5 minus 1. So we figured out, okay, well, what is f of 5? So we got 3 times 5 squared minus, now this f of 1, we already did over here previously, and we ended up with 3. So we really don't have to recalculate that. We know what that value is. 5 minus 1 is 4. So let's see, doing order of operations, 5 squared is 25 times 3 is 75, minus 3 still over 4. 75 minus 3 would be 72, and 72 divided by 4, let's see here, 72 divided by 4, that's going to be, what's it, 1 with 3, how about 18? So that should end up being 18. So that's the change in y over the change in x. So the average of the rate of change is going to be 18. Let's do the same thing for letter C. And I've not said this in every video, but hopefully you are doing these. Every once in a while, if you feel like you've got the idea, either fast forward ahead until you get to another piece, or pause the video here, calculate what is the average rate of change from 1 to 7, and then see if you end up with the same thing that I have. So pause the video and then recalculating is a wonderful thing to do. So let's see, so letter C here, we got change in y over change in x. So f of 7 minus f of 1 is a change in y's. 7 minus 1 the change in x's. So we would have 3 times the square of 7 minus, we already know f of 1 is 3, in this case now over 6. So let's see, we got 3 times, in this case, 49, minus 3 all over 6. Now, if this was 3 times 50, that would be 150. but I'm 1 off of 50 3 different times. So I want to take 3 away from 150. So that's another way to do that calculation. That'd be 147 minus 3 over 6. And let's see, so 147 minus 3 is 144 over 6. And 144 divided by 6, let's see, 4, so 24. So it's change in y over change in x. So that ends up being 24 in this case. So what did we just do? We calculated the average rate of change between any 2 points. Let's take a brief look at that as far as in Desmos. And let's see. So we had, here's our function. So we've got 3x squared. And then we had the point 1 to, so when from x went from 1 to 3. So I can go ahead and say, okay, what is the point at 1, 1, or excuse me, at 1 w of 1? And so that looks like that is the point A here. And that would have been the point, what, 1, 3. Then at 3 w of 3, we're going to call that point B. If I zoom out here, there we go, there's point B. So what we want then is we want the rate of change between those 2 points. And so we're looking for the slope. Now, we've got it down here. We already calculated it was 12. Graphically, though, if I go ahead and plug this into an equation, I've got the in point slope form, y minus the y value equals the slope times x minus an x value. So I'm using 3 and w of 3, and that is the graph here. So we see this particular line from A to B, and it doesn't follow along the curve exactly because the curve is a curve and the line is a line, so they're not the same things, but they do follow along each other fairly tightly. And the rate of change from A to B, if I would calculate the slope, so if I would count up how far I'm going and then count over, that would end up telling me what that rate of change would be. So from this point going up, so this is the point, what, 1, 3, and then I go up to, what, 327. So 3 to 27 is a change of 24. From x value of 1 to 3 is a difference of 2. And so we end up with 24 over 2. And that is the same thing that we ended up back with up over here. And we ended up with the average rate of change was 12. So again, we're just taking a look at effectively the slope. That brings us then into, and I've used that, used Desmos to take a look at the equation for a line, and the slope of a secant line, the average rate of change of a function from A to B equals the slope of the secant line between any 2 points, A f of A and B f of B on its graph. And really, that's the only thing that we did in example 7 here. We very consistently took a look at these points here, the change of in the y's over the change in x's. So if I take a look at those a little bit further down here, what my y's are the f values. So f of b minus f of a. Those are my y values. My change in my x's then would be b minus a. So that's change in y over change in x. So a secant line is just a line that crosses a graph at 2 specific points. So we take those 2 points, if we calculate the slope, that is the slope of a secant line. Last example, example number 8, finding an equation of a secant line. And then we're going to do that with point slope form here, but let's take a look at what else we can come up with this specific example. Suppose that g of x is 3x squared minus 2x plus 3. Whoops, I was going to highlight that. Get my highlighter, there we go. So there's the item I'm looking at. Let's find the average rate of change of g from -2 to 1. Okay, so on letter A, we want the average rate of change, so that's the slope. We're going to really the slope of the secant line, and so we want from -2 to 1. So f of 1 minus f of -2 over 1 minus -2. So we got double negative there. So that's going to end up being my rate of change. So if I want f of 1, I can go ahead and plug this in here. So I want 3 times 1 squared minus 2 times 1 plus 3. So that piece there is just f of 1. That's all of f of 1 minus, now let's do f of 2. So I mean f of negative 2, I should say. So f of negative 2, so I get 3 times negative 2 squared minus 2 times negative 2 plus 3. And this is all over 1, and I got a double negative there, so 1 plus 2. Now, one thing that we could have done, okay, is I could have taken this whole thing in yellow here and separated that and done that by itself. Could have taken the piece in blue here, separated that out, done it by itself, and then just wrote those values in there. Okay, so that is another way that we could have done that. Let's do it this way. So 3 times 1 is 3. And I got minus 2 plus 3. I got minus, let's see, the square of negative 2 is 4 times 3 is 12. Got double negative, so that's going to be a plus 4, and then plus 3. So again, finishing with order of operations, 3 plus 3 is 6, minus 2 is 4. Minus, let's see, 12 and 4 is 16, and 3 is 19. So we have negative 15 over 3, which ends up to be negative 5. So the rate of change here between the points from x values from negative 2 to 1 is negative 5. Now part B, let's find an equation of the secant line that contains those 2 points. Okay, let's see. So if I want to find the equation for secant line, one of the things I can do is y minus the y value equals slope times x minus the x value. That is point slope form. So let's choose one of these points. Let's choose 1 and f of 1. So if I choose 1 f of 1 as my point, let's see here. What was f of 1? F of 1 was whatever this value was here, and that worked out to be this item, which worked out to be 4. So I'm at the point 1, 4. So I can do y minus 4 equals my slope. So the slope between these items was negative 5. And then x minus the x value. So if all I want is an equation, that's the equation or an equation that would work. I could have also then plugged in negative 2 and 19. Negative 2, 19 would have also been acceptable for that one. And so when we take a look at equations of lines, I either have point slope or slope intercept. In point slope, since there's an infinite number of points on a line, there's an infinite number of equations in point slope form. There's only one y-intercept, so if I solve and put it in slope-intercept form, then I have exactly one equation that I can end up with. So for the sake of argument, let's go ahead and take this down to slope-intercept form. So in that case, I'm going to distribute this 5, or negative 5, so it's negative 5x, and then plus 5. And if I add this 4 to both sides, let's see, then I get y equals negative 5x plus 9. So depending on which format we're asked for, if we're asked for just an equation, then this first equation here would work. If we're asked point slope, then the one I've already got highlighted would work. If we're asked for slope intercept, then we have to do the one that is in blue. Okay, so that is finding the slope of a secant line. All right, and that wraps up. That is part 2 of the videos here on section 3.3, properties of functions. So overall, we had taken a look at maxes and mins, both local and absolute. We saw where functions were increasing, where we were decreasing. We also identified whether functions were even or odd based off their graphs. Then we took a look at, here at the end, the average rate of change of a function. So like in any other video, if you happen to see that there's a mistake somewhere, please go ahead and drop me a line and let me know. Otherwise, that's the end of section 3.3. And in section 3.4, we'll take a look at what is called the library of functions, and we'll do that in our next video.